Hi, everyone. Welcome to week 10 of the weekly CTF challenge. I'm Jessica, and I'm joined today by Jamie.
Hey, hello. How's everybody?
Thanks so much for joining us. How was your weekend, Jamie?
It was good. I went fishing, had an enjoyable time. It's a little chilly here to fish, but it's one of those things where you got to get away, even during the pandemic. The good thing is I didn't have to social distance from anybody because fish don't get COVID, so it was all good.
I love it. I love it. I love it. So we're going to start off for a quick moment playing the recording of the challenge week 8, the last Linux solve. So we're going to take a pause right here, and Allie's going to go ahead and show the pre-recorded solve.
So the question again was what packages did the what package did the threat actor install, and what was the reason they installed that package? So I already loaded the image. It's already mounted and parsed. All of it is under a directory. I put it here on a directory called master because it's the master image. Now, one thing which is very important to understand when going further with especially dealing with Linux or with any operating system is to understand where the evidence could be located. So if we want to understand where the packages are located, then where the packages are located, and also any logs about those packages, we need to understand where they are located. So they are located in the var log directory. So we have that. There are a couple of files. Each one of them will store evidence about packages being installed, and we will check those out. So since we are talking about here a Debian-based system, which is Ubuntu, then that means we are talking with APT package manager. So as you can see here, we have a directory called APT. So it will store all the information about APT. And I think Mike in the previous week also mentioned this. So if you haven't seen that from the previous week, then this is another opportunity for you to check that out. We have two files, as you can see, the history. So history here is telling us the history about, let's check the tail of it, history of the packages which have been installed. So if we just check that, we can see we have here, at least at the end, I can throw maybe more than just to say, let's say here, just so we can have a broader idea about the packages installed. So if we look in the history here, all of those packages were installed in 2017. All of them, if we look here, the starting date of the installation was in 2017. But the only one which is in 2019, which is where our let's say incident happened, or when we noticed the incident happened, was in 2019, and that's actually when the system was compromised. So we can see here that on 2019 October 7th, this is, by the way, not in UTC, this is in BST, I think. It's in Brussels, I think, time zone. And we can also see even the package, the command line that was used for the installation. So we can see very clearly that the package that was installed is PHP. That's the answer. And we can see the whole command which was used to install the package. So that was the answer to part number 1. So now we know that PHP was the one installed. We know, let's say we have an idea of our incident, the time frame where it happened. So what we could do is use that log file. So we can do a find. So if I do a find, my cases are all under cases and HDFS master. And we can use, so Linux has a good tool, so we can use find, but Linux has a good option with find that we can use a file as a reference to search for other files. So what we can do here is say, I want a file which is newer, or we can even specify a date. Let's go with the date, newer than 2019, October, let's go with 05. So if we go back maybe one day, in the past. Okay, and we can then do minus newer, because we want to put it like a time frame to search for, and say October 2019, October, let's say 08. That way we will be searching for all the files which are newer than 0508. So now we got this list. So actually we can, it's better to throw them into cases, HDFS. So let's create a file, files, let's say found.txt. And then we can actually, yeah. It's also good if we have some permissions issues, we will run with sudo. That way we can avoid that. And even if a file doesn't have, we don't have permissions to access it, now we do. And now we can search through like the txt file. So over here, this will require like going through it and understanding, for example, what is there. So we can see under USR bin PHP, those files were accessed and modified for a reason, that the PHP package was added. So that's why we see USR bin was modified, because now the directory has been added in that directory. So we can see all of these are related to the PHP. We can also see the share directory got modified. Why? Because Linux does not put all the package, let's say the package and the tools which come with it under one directory. There's a specific structure, and that's the Linux standard that let's say the documentation has to go under share, the binary files has to go under USR bin, etc. So each one will go under a certain directory. Now, if we understand all of that, we can skip that. It will make our life easier. As you can see, these are all part of the PHP installation itself. So probably we can skip those. Over here, we can see these are normal. If you have an idea about Hadoop, then you'll know that these are normal HDFS activity going on, like new FS images are being created, updated, any HDFS activity going on. If we go down more, we can see also these are, now we are talking about the etc directory, which is where we find all the configuration files, and you can see all of those are also updated. Why? Because of the PHP package has been installed. So you can see that we can really even minimize the scope of our search and the files we are looking in, just by knowing that when we install a package, what's going to happen with that. So probably all of this is normal, unless we want to investigate the package installed itself. That will be a different story. So all of these are still normal. All of them got updated. But then once we get here is where things get a little bit weird. So here we are now talking about the systemd, which is the main service or the main system controlling, I would say briefly, all of the Linux system and processes. In the past, it was INIT. Now it's systemd. They are using this service. And we can see this system also got updated. So we can see something got updated here. That's one thing. We can see based on, we also need to understand how systemd, the system works. So it works based on multiple targets, and you can specify those, and each target will, like, if you want under a GUI setup, you want something to be prepared for your system before that works, then you will specify what you want as a setup to work. So also basic understanding of how systemd, by the way, works will help you in here. So we can see those files were also created, and the find was looking sequentially. So that's why this came up. And we can see that we have something called the cluster.service. If you know Hadoop, there's no such thing as cluster.service unless someone created this service or something there. We can also see under multi-user target.once. So this is again what systemd will specify, that I need these files or I need these services in order for my target to run. So you'll specify those here, and it says the cluster.service. And then the weird thing which happens is we can see the PHP service being referenced there. So why is a PHP being referenced by systemd? PHP, if it was referenced by Apache or any other web application server, that would be normal because that's how it works. But being referenced by systemd is actually weird. We need to check that. So if we go down over all of this, we can see all of these were about the Hadoop files being updated. We can see all of them also about syslog, because syslog did get updated once we installed the file. The PHP log was created. All of those activities, we see all of those between that time frame between October 5th and October 8th, because that's when the incident happened. But the one that stood up for us was our cluster file. So we need to check that. So now if we take, and these, by the way, you can, if we go through them, you'll see they are, I would say, normal activity which happened. Like you will still need to check them probably if you made to double check, but that one, I would say, since it's very weird and it stood up out of all of the search, which we started from bottom to top, we should search that one first. So that's why I'm gonna exit. What did I do wrong here? Please exit. Oh, again, yes. So if we go check that, let's just add sudo just in case. So we can see here, this is the configuration for the service, the cluster service. So it's telling us this is a daemon cluster service. I've never heard about that before. We can see it's telling the service to start after the network target. So it's clear that this service depends on the network target. So we need network in order for this to start. Start limit intervals, so it immediately will start the service. It's a simple service. Restart always, so this way, even if the service, let's say, crashes, it will restart itself automatically. Systemd will keep that restarting. Restart sequence, keep it 1, and we can see the user is the user root. So this is run under the user root, and we can see the command which is executed is under the exec start. We can see the USR bin environment PHP. That way the threat actor can, if now we can say about that, regardless where PHP is actually installed, ENV will search for where PHP is installed, call it, and then use PHP to run this file. So we need to check that file as well. And that's what we are going to be doing. And as you can see, it's installed under the multi-user target. So now if we check our, let me just go back to cases HDFS. And now if we go to cat master USR local Hadoop bin cluster.php, let's do that. But let me just add sudo to make sure. We can see that we have a PHP application, and that PHP application, what it's doing really is it's creating and it's binding a socket to 000. So that means regardless from any interface, it will be listening on all interfaces, and it will be listening on port 17001. So after that, once the user connects to that, port, they will be given a shell. So that way they now can interact with a shell. So they actually have a remote shell on the system. So this is a way that threat actor will use systemd to install a backdoor on the system and have access to the system as long as the system is running, because it's running under root. It's running as long as systemd is running, and systemd, your system will not be running if systemd is not running, and that way they have a backdoor access to the root system, to the system with user root. So that was the solution to this.
That's great. Wow, I just learned a lot. Yeah, that's awesome.
I learned so much. Thank you, Ali.
That was brilliant. To be honest, I learned more in this walkthrough than I think I have in any of them. Thank you so much, Ali, for being our guest questioner, and also for walking us through this incredible walkthrough. My Linux brain has been expanded. Thank you. Well, I hope you really all enjoyed that. Ali worked really amazingly on that challenge, and just thank you to him and the rest of the team at Champlain for putting together that image set and allowing us to use it. But I know now we're on to memory, thankfully. That Linux set was hard. I hope all of you enjoyed Aaron Sparling's challenges last week on this memory image. I know I did. I enjoyed. I can't wait to read your blogs this week. So let's introduce, before we introduce the next challenge, Jamie, do you have a question to share for the Trivia for Discord?
Trivia question for me. I think if you look around on different places, you'll be able to Google me and find out this answer pretty easily, I think. How old was I when I joined the military? And I've only been in one branch for a consecutive amount of time, so it should be pretty easy to figure it out.
So none of this sneaky joined one branch, joined another branch at this age, none of that.
Nope, none of that.
So the question for everybody, first one in Discord with the answer: at what age was Jamie Tubbs our director of training when he joined the military? Awesome. So now the questions everybody are really excited about. How many parts is your challenge this week for memory?
Yeah, so I'm a RAM junkie, right? I really like RAM. I like RAM investigations. I believe that as a forensic community, we've sort of we're a little bit later on the coming up with RAM, and it's not because I think that we mean to. It's just like most of it's dead box, right? Like not everybody gets a live machine running, and it's good when you do, but because of that, not everybody does RAM forensics. But I didn't make it easy because it's called the RAM. So it's a 5-part questions, and the reason why it's 5-part is because you can't get really to part 5 without getting there from part 1. So
I love that because it gives you the opportunity to learn too, right? Because you're finding one thing, and instead of just asking that question that's 5 steps out, it kind of walks people through the workflow and journey that they would need to take to solve it.
Right on. That's exactly the correct thing. I mean, the whole idea behind RAM forensics is expose ourselves to something we may not do, and if we already do it, let's hone our skills, right?
I would expect nothing less from somebody who has spent as long as you have building forensics training programs.
Okay, I got a little gray going. Let's not go down.
That's not what I was implying.
I don't know. I'm catching that. I'm a little sensitive about it. All right.
So I know it's a 5-parter and that each one unlocks the next. What is the first question?
So the first question has a little bit of an intro as well. So just to make sure we set the stage and everybody has the same expectations. But at the time of the RAM collection, which I'll go ahead and give you two, you can get it from within the image, and that's coming from Image Info. So at the time of the RAM collection, which was 20 April 20 at 23:23:26, and again, I got that from Image Info, there was an established connection to a Google server. My question is, what was the remote IP address and port number for that connection?
Ooh, I like it. Good
and
question.
Then that one will lead you to the next one and the next one and the next one, which if you get the first one right, you'll get another question, obviously, and so on. So.
Well, that's good too, because it means there's lots of points up for grab this week too for people who are competing. And just as a reminder, even if this is your first week playing, there's still prizes for people who submit answers each week, in addition to the grandiose winners at the end of this year. So finishing up later this month. I can't believe it's already December.
Oh,
so speaking of finishing up this month, for those of you who are hanging out now, please feel free to join me tomorrow on Cash Up. Catherine Headley will be our guest. If you're not familiar with her, she's a SANS author, one of co-authors for 308. She's also a great examiner out of the UK, and really has some interesting stuff to talk about that's going on with DFIR Fit. So it'll be fun to talk about some of that DFIR Fit stuff, maybe a little bit about a holiday challenge, and more. So stay tuned for that and enjoy this week's challenge. Thanks so much, Jamie.
Good luck on the challenge.